This is actually a geometric progression. Our concern in this video is to see how to find the sum of infinite geometric series. But here is the geometric series itself, which in one of our videos we have explained how to find the sum of a geometric series. And we said that Sn in this case will be the same thing as a into 1 minus r raised to power n all over 1 minus r, where my a is the first term, that's the first term, my r is the geometric ratio. Let's take an example. If I have this series s of n to be equals to 20 plus 4 plus 0.8 plus 0.16. Now this series continues this way. Now if this series you agree with me that my a is equals to 20, and I can easily look for my r because my ar is equals to 4. So that this implies that my r will be equals to ar over a. Then my r will be equals to 4 over 20. 4 here is 1, 4 here is 5. This is the same thing as 1 over 5. 1 over 5 is the same thing as 0.2. Now, if r is equals to 0.2, we can find the sum of any part of this geometric progression. Take for example, if I want to look for the sum of the first 5 terms, S5. S5 will be the same thing as A is 20. My R now is 0.2. That will be 1 minus 0.2 raised to power 5 all over 1 minus 0.2. This obviously will be the same thing as 20 into 1 minus 0.2 raised to power 5. Let's get that with our calculator. So that 0.2 raised to power 5, that will be 0.2 raised to the power of 5. That will be the same thing as 0.0032. That will be 1 minus 0.00032 all over 1 minus 0.2. Obviously, that's 0.8. Let's pick another slide. Now, so that my S5 now will be the same thing as 20 into 1 minus, now 1 minus 0.0032, that's 0.00032 all over 0.8. Now 1 minus 0.00032, this is 1 minus 0.00032. That's 0.99968. Now that's the same thing as 20 into 0.99968 all over 0.8. So that S5, this is S5. S5 will now be the same thing as 20 times, let's use our calculator. 20 times 0.99968, that's 0.9999, just 19, I have to take 1968. I want to be very exact. That's 19.99 divided by 0.8 divided by 0.8. That's equals to 24.992. That's equals to 24.992. 24.992. Now we have only looked for 5 terms. Now let's imagine that this series extends to probably 50 times. Now if this series is going to extend to 50 times, then we'll be looking for x50. From our formula, we'll be saying that this will be equal to a into 1 minus r. A, we know my a is 20. Let me just use 20 here. My r is 0.2 all raised to power 50 all over 1 minus r again, that's 0.2. Now, if you look at this closely now, you begin to see that my 20 now a into 1 minus, look at 0.2 raised to power 50. That's zero point 0.2, no, 0. That's zero point 0.2 raised to the power of, I'm raising it to the power of 50. That's equals to, now look at this. You see that this is equals to 1.1 times 10 raised to power is e minus 35. That's 1.125 times 10 raised to power minus 35. This is 1 times 10 raised to power minus 35. That's 1.2 times 10 to the power minus 35. Let's see. 1.12 times 10 1.12. But the most important point is when you look at this, it is next to 0. This is next to 0. This is almost becoming 0. If the series is now going to extend to probably 100, if I'm going to have s raised to power 100, then I'll be raising 0.2 here raised to power 100. So let's see what 0.2 raised to power 100 will look like. When you now do 0.2 and you raise it to the power of 100. Now that's 1.2 times 10 raised to the power minus 70. So as as my n begins to tend to infinity, my r raised to power n in this case is beginning to tend to 0. Now we have that s raised to power n is the same thing as a into 1 minus r raised to power n all over 1 minus r. We have shown that when r is less than 1, we have shown that the value of r raised to power n begin to tend to what is approximately 0. So that my s of n at infinity, as the whole series tends to infinity, becomes a into 1 minus 0 all over 1 minus r. So that this is the same thing as a is equals to a times 1 here obviously is a over 1 minus r. Anytime we are saddled with finding the sum of an infinite geometric series where r is less than 1, s of s to sum of infinity is the same thing as a over 1 minus r. A over 1 minus r. With this, I hope you understand how to treat finding the sum of infinite geometric series. Thank you for staying with us and see you in another class.